Hello everyone, this is Mr. Hauk. In this video, we're going to look at how to solve basic trig equations. You will need a unit circle for this video, for this set of notes, so go ahead and have a unit circle ready, and let's go ahead and jump into it. So we're going to start with the activating strategy. And the activating strategy has us solving each of these following quadratic equations, a skill that you learned in Algebra 1. So looking at our first one, 4x squared minus 20, there's a couple things we can do here. One thing I'm going to do is I'm going to go ahead, add the 20 to the right side, really add 20 to both sides. Now we have 4x squared equals 20. Let's go ahead and divide 4 from both sides. You get x squared equals 5. And to remove the squared power, we're going to take the square root of both sides. And we get x equals, now remember, when you're taking the square root of a number like that, like the square root of 5, when we're introducing the square root into the equation, we need to have that plus minus sign. So x equals plus or minus the square root of 5. Yep. Okay, and our second quadratic equation that we're going to solve, we're solving 3x squared minus 9x equals 0. A couple things one thing we can do here is I see a greatest common factor of 3x that I can factor out. I'm going to go ahead and factor out the 3x. If I factor 3x from 3x squared, I'm just going to get x. If I factor 3x from negative 9x, I'm going to get minus 3. All right, and remember, you can always double check by remultiplying 3x times x. That's 3x squared, good. 3x times negative 3, that's negative 9x. Now, now that this is factored, when you have two factors multiplying together, notice this 3x times x minus 3. When we have two factors multiplying together and they're equal to 0, the zero product property kicks in. We can set each individual factor equal to 0. So we can say 3x, the first factor, equals 0, and x minus 3, the other factor, equal to 0. Okay, well, if 3x equals 0 and you divided the 3 on both sides, you would get x equals 0. In the second one, we would add 3 to the right side, and we would get x equals 3. Okay, now remember, every time we have a warm-up or an activating strategy on our sets of notes, it's there for a purpose. It's going to serve some kind of purpose for that lesson that we're learning that day. Okay, so our lesson, our goal, is we want to solve trigonometric equations. And in this particular set of notes, we're going to keep to very basic trigonometric equations. You'll see in the next set of notes, they'll get a little bit more complicated. The factoring will get more complicated. But we're going to stick to solving basic trig equations today. Now notice it says solve. So here's our problem, example 1. Solve 2 cosine x minus 1 equals 0 on the interval 0 to 2 pi. Okay? So we want to find all solutions to this equation on this specific interval. We have to limit our interval because if we don't, we have the possibility for having an infinite number of answers. So we are only looking from 0 to 2 pi. This is one of the reasons we definitely want to have our unit circle available to us, because the unit circle is going to go from 0, wrap around to 2 pi. Okay? So, looking at this here, just like we solved these equations up here in these warm-up problems, the goal was we were getting the variable by itself. Okay? We're working it down until we got the variable by itself so we could solve for it. We're doing the same thing here. We're trying to get the trig function by itself. You can almost think of it like this. Think of this as solving 2x minus 1 equals 0. Okay? Instead of thinking cosine x, think of cosine x as the variable we're trying to isolate. Okay? So we want to isolate this cosine. Well, if we're going to do that, so we have 2 cosine x minus 1 equals 0. Let's go ahead and add 1 to both sides. Now we have 2 cosine x equals 1. Let's divide the 2 on both sides to get the cosine x isolated. Okay, now we have cosine of x equals 1/2. So now what we're trying to figure out, we have cosine of x equals 1/2, and we're on the interval 0 to 2 pi. So we want to figure out every single angle from 0 to 2 pi. What are all the angles that have cosine values of 1/2? Okay, so we jump over to our unit circle. Remember, the cosine value is the x value. Here's an x value, a positive 1/2, here at pi over 3. And then we have another x value of 1/2 at 5 pi over 3. And those are the only 2 x values, the only 2 cosine values of 1/2 that I see. So x equals pi over 3 and 5 pi over 3. Okay. Example 2. Solve 4 sine squared x minus 3 equals 0. Again, on the interval 0 to 2 pi. Our interval is always going to be 0 to 2 pi. So this is the equation that we're going to try to solve. Now, one little note that I'd like you to make, that I'd like you to have in your notes here. When you see this sine squared of x, sine squared of x is the same thing as sine of x squared. Okay, it's the same exact thing. So again, just like we were previously, I told you kind of how to think about this when solving it. The way we want to think about this one, we want to be thinking 4x squared, sine of x is really what we're trying to isolate. We're trying to isolate for the trig part. So we want to think 4x squared, since we have 4 sine squared, minus 3 equals 0. Okay? So think of this sine squared as an x squared in terms of like the equation solving process. All right? So we have 4 sine squared, or 4 sine of x squared, minus 3 equals 0. Okay, let's start working on getting the sine of x isolated. So the first thing that we need to do is add 3 to both sides. Now we have 4 sine of x squared equals 3. Divide the 4 on both sides. Get the sine of x squared isolated. Sine of x squared equals 3/4. Okay, and just like in the warm-up above, if we wanted to remove this power of 2, we would take the square root of both sides. But if we take the square root of both sides, we have to have this little plus minus symbol. Okay, so now we have sine of x, we got rid of the power of 2, equals plus minus square root of 3/4. Okay, now look at this square root of 3/4. If you're taking the square root of a fraction, you can take the square root of the top and the square root of the bottom separately. So we can look at this instead as sine of x equals plus or minus square root of 3 over square root of 4. Okay, and the reason that's nice is because if you look at that denominator, square root of 4, well, the square root of 4 is 2. So this is really sine of x equals plus minus square root of 3, which we can't take the square root cleanly, over 2. Okay, so now the problem is having us look at, we want to find all angles from 0 to 2 pi that have sine values of either positive square root of 3 over 2 or negative square root of 3 over 2. So we're looking for positive and negative square root of 3 over 2 for the sine values. And we know the sine values are the y values. So let's jump over to the unit circle. We want to find every single y value that either has a positive or negative square root of 3 over 2 value. Well, here's one, pi over 3. Here's another one, positive square root of 3 over 2 sine value, 2 pi over 3. Here's another one, 4 pi over 3. And here's the final one, 5 pi over 3. So x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So this one we had 4 different solutions in our solution set. Now, quick little note that I want to talk about, going back to this, where we took the square root of the top and the bottom separately. Let's say that the denominator, we could not take the square root cleanly. Then, if you remember back to stuff we did first semester, then we would have to multiply top and bottom by the square root of whatever that denominator was to rationalize the denominator. You'll see that you'll end up seeing that pop up on the classwork and the practice. Okay. All right, final example in the notes. Actually, not final example, 2 more examples. So second to last example. Now we want to solve sine x times tangent x minus tangent x equals 0, again on the interval from 0 to 2 pi. So this one, a little bit different. Up here we were saying, think of it like this, think of it like this. Well, there was only one trig function to isolate. Here we have 2 different trig functions, but if we look at it, sine of x times tangent x minus tangent x, they both have a tangent that we can factor out. So I'm going to start by factoring out the tangent. So factor out tangent x. If I factor tangent x from sine of x times tangent x, I'm going to get sine of x. Carry down the minus. If I factor tangent out of itself, I'm going to get 1. Okay? And just like in the warm-up, if we have something factored, if we have 2 factors multiplying together and they're equal to 0, we can set each individual factor separately equal to 0. So here we'll have tangent of x equals 0. Here we'll have sine of x minus 1 equal to 0. Okay? So tangent x equals 0. Again, we're going to go to the unit circle, find all angles from 0 to 2 pi where the tangent value is 0. On my unit circle, these orange values, these yellowish orange values, these are all the tangent values. Remember that on the unit circle you get on quizzes and tests, it doesn't have the tangent values, so you need to commit them to memory. But we can see that the tangent values that have zeros, the 0 tangent values, are happening at here, 0, which is also the same as 2 pi, and here at pi. So for this one only, where tangent of x is equal to 0, we have x equals 0, pi, and 2 pi. But we also have this one right here. So let's go ahead and add the 1 to the right side. We get sine of x equals 1. And now we're asking ourselves, same deal, from 0 to 2 pi, what are all the angles that have sine values, y values, of 1? Well, the only y value of positive 1 that I can see is right here at pi over 2. So x equals pi over 2. Okay, so we have 1, 2, 3, 4 different x values in our solution set. X equals. Now, me personally, I always put them in order. You don't have to put them in order, but it's something that I do. 0, then pi over 2, then pi, then 2 pi. Okay. Final example, we're going to do an application problem. All right, so example 4, at the county fair, the distance from a person riding the Ferris wheel to the ground is modeled by the function h of t equals 40 sine of pi over 18t plus 5. We want to know at what time or times will a rider be 25 feet from the ground. Now, we left out one tiny little detail here. Let me include this detail. I actually want to say in the first 30 seconds. Okay, it's kind of like how we've been limiting these intervals from 0 to 2 pi. If we don't limit the interval from 0 to 2 pi, you can technically have an infinite number of answers. So I'm just going to say at what time or times in the first 30 seconds will the rider be 25 feet from the ground. Okay, this is just going to allow us to limit our answers so that they're not an infinite number of answers. Okay, so we want to know, here's our function. This function is telling us the height. H of t is representing the height that a person is off the ground. We want to know what times, so we're finding t, just like up in here in these examples we were finding x. What time will a rider be 25 feet from the ground? So that's going to represent the height. So we're going to take our height function, 40 sine of pi over 18t plus 5. We're going to set it equal to 25. We want to know, when is this height function going to give us a height of 25? Okay, now we're just going to start solving it like normal. Let's go ahead and subtract 5 from both sides. That's going to give us 40 sine pi over 18t equals 20. So subtracted the 5 from both sides. Let's divide 40 from both sides. Sine of pi over 18t. If I divide 40 on both sides, 20 divided by 40 would give me 1/2. Okay, so what we're trying to say here is we're trying to say sine of something is equaling 1/2. Now in all these previous examples, it was just like tangent of x, or sine of x, or cosine of x. So we want to know, when is sine going to give us 1/2? And we're going to take whatever this is, whatever this argument is in here, we're going to set that equal to those angles where the sine value is 1/2. So we jump over to the unit circle. We can see our sine values are 1/2, positive 1/2 at pi over 6, and at 5 pi over 6. Okay, so we're going to say pi over 18t equals pi over 6 and 5 pi over 6. Now, I'm not interested in pi over 18t. I want to find the t values specifically. So what I'm actually going to do is I'm going to multiply both of my angles here, both of my solutions, by 18 over pi. Notice I'm choosing 18 over pi because if I multiply that here, those are going to cancel and leave me with a t. So I'm multiplying everything by 18 over pi. This, the pi over 6, and the 5 pi over 6. Or, sorry, 18 over pi. There we go. Okay. So again, what that's going to do, that's going to leave us with just t, because 18 and the pi will cancel. It's going to leave us with just t equals, well, if I do 18 over pi times pi over 6, pi is cancel. 18 divided by 6 is 3. And then here, if I do 5 pi over 6 times 18 over pi, pi is cancel. 18 divided by 6 is 3. 5 times 3 is 15. Okay, so I get t values of 3 and 15. I also don't see any units here for time, but I said 30 seconds, so at 3 and 15 seconds. Okay, so that's going to cover it for these notes. That's how, these is just the basics to solving trig equations. You have a classwork assignment right after these notes, so work with the people at your table, solve those equations on the classwork assignment. I'm going to put the key up online so you can check your answers to the classwork assignment, and then turn in 1 copy of that classwork assignment per group. Make sure everybody's names are on that classwork assignment. All right, have a great day.